Okay, so on to page 2. Let's do this little jump rope problem here. It says two people swing jump ropes. The highest point in the middle of each rope is 80 inches above the ground, and the lowest point is 2 inches. The rope makes 2 revolutions per second. Write a model for the height in inches of a rope as a function of the time t in seconds, given that the rope is at its lowest point when t is equal to 0. Okay, so in order to start this problem here, I'm going to use that last piece of information which says that the rope is at its lowest point when t is equal to 0. And that's going to determine what kind of function I have, whether it's a sine function or a cosine function. And if you remember for your cosine function, if I can just sketch it out here on the side really quick, my cosine function let's say this is t is equal to 0. Remember, the cosine function starts at the amplitude. It's going to look roughly something like this, and stop at 2 pi, right? And so, in order for me to determine, if the rope is, if this equation is using a sine function or a cosine function, at t is equal to 0, notice here, this is my parent function for the cosine function, it's at a max. And on this one right here, it says, given that the rope is at its lowest point when t is equal to 0, so that means it's going to be at a min. I'm still going to use the cosine function, because at t is equal to 0, right, this is my cosine function, it's at the positive amplitude. In fact, to make it at a minimum, right, all I need to do is reflect it across the x-axis. Okay, so what I'm going to do right now is just write my parent function, h of t, is equal to a cosine b of t, and we are going to assume that this equation does not have a phase shift. Okay, so we need to calculate what the amplitude is, what the horizontal shift is, and of course the midline. All right, so let's see if we can kind of draw a picture of this jump rope over here, just so we can kind of visualize what's going on. Okay, so I have some kind of jump rope, and it says it's going to have a max at 80. And it's going to have a minimum, or sorry, the lowest point is going to be at 2 inches. Okay, so I can extend this out a little bit further here. At t equals 0, right, it's going to have a min. So roughly it's going to look something like this. Okay, so there's just a rough sketch of the picture. You don't have to draw it to answer this question, but those of you who are visual learners, such as myself, it's very helpful, okay? All right, so, well, we can start calculating the individual quantities that we need, right? We need the amplitude, and the amplitude is given by 1/2 max minus min. Okay, so the amplitude is 1/2, the maximum is 80, minus the min, which is 2. And you're going to have 39 over here. You also need the midline, right? The midline, which is determined by the k value, is y is equal to 1/2 max plus the min, right? So 80 plus 2, you're going to get 82 divided by 2, which is 41. And the very last thing you need to calculate, right, which is your b, is determined by the period. And now, we go back to the problem right here, right, it says the rope makes 2 revolutions per second. This 2 revolutions per second, this is just the frequency. Okay, so the frequency is 2. And if you remember the relationship between frequency and period, right, the frequency is 1 over the period. Okay, 1 over the period. And just to give you a little more math over here, the period is 2 pi over b, right? And we can calculate, right? If the frequency is 2, we can now solve for what b is. Okay, so make sure you do a little cross multiplication over here. You could say 2 is equal to b over 2 pi. And then you can cross multiply. B is equal to 4 pi. And that will be your B. Okay, so you have your B, you have your K, you have your A. And remember when we write our final answer, right, because back in the original problem it says the rope is at its lowest point at t is equal to 0, that means we need a reflection across the x-axis. So when we write this, we don't want to write positive 39, we want to write negative 39, right? Because remember, if this is our parent function, right, normally it would not need a negative a, right? If this is f of t is equal to cosine t, but because it's reflected across the x-axis, or sorry, it's at its lowest point at t is equal to 0, we need a reflection across the x-axis, which means we need to place a negative here. Okay, so finish up this problem, cosine of 4 pi parentheses t, and then plus k, our k right here is just 41. Okay, so it's kind of a lengthy word problem, but really it's just asking you to write the equation of the graph. And you already know these formulas over here, and amplitude, midline, and your frequency over here. This might be a little bit tricky for some of you, but really this is just practicing your algebra, right? 1 over 2 pi over b is basically b over 2 pi, and then you cross multiply to get b. Okay, so once you have all the values, you just plug it in, and that will finish up your problem.